Hey guys, welcome back to the garage. Today we're going to do a quick video on the instrument cluster on these BMW E30s. When I went through and changed the instrument cluster on this car, I did a lot of diagnostic work just to make sure that my problems were in the instrument cluster itself and not in the wiring harness or some other electrical component of the car. Now I noticed I got a lot of comments on that video wondering, well, how did you go about diagnosing the wiring, making sure the instrument cluster was getting correct power and all of that? Well, I decided I might as well put a video together since I've got to take the instrument cluster back out to replace the odometer gears anyway. Let's take a look at the things we'll need to do these tests. Okay, so everything you'll need to test the instrument cluster power connectors is a voltmeter like this. This is just a cheap one I got at Harbor Freight. In fact, I think I got it for free with a coupon. I mean, you can pick these things up all day for about $6 from a lot of discount tool stores. We'll want one that can read direct volts. The way we'll have this set for this test is on these 200 on the DCV side. This is so you can see 12 volts and any sort of 10th reading that follows the full voltage. You'll also need the leads that come off of that. So you've got your positive and negative leads that come off of your voltmeter here. Then we'll want to get some extension leads with alligator clips on either end. And then you'll want to get an unpainted safety pin, a small one, because this is how we're actually going to probe the individual sockets on the connectors that go into the instrument cluster. You'll also want to get a piece of paper so you can draw out the diagram of each connector going into the instrument cluster. This will help keep everything organized and keep your readings straightforward. Now, if you're experiencing issues with your instrument cluster, whether the speedometer is not working, the tachometer, or any of the other gauges are not working, the first and easiest thing you can do is check the fuses. The fuses that apply to the instrument cluster are the 10, 12, and 21 number fuses in the engine compartment. So the first thing you want to do is check those and make sure they're all good. Usually they are. I checked mine like 3 times and they were always good, but I kept going back and making sure that they were fine, because who doesn't want a fast, easy fix like that? But usually the problems aren't there. There's something else within the cluster or in the wiring somewhere. So assuming you've checked all those, the next thing we want to do is remove the instrument cluster from the car. I'm not going to do a detailed step-by-step on how to do this. There's tons of tutorials out there, so I'm not going to cover that in detail. I'm just going to do a quick time lapse of me removing it, and then we'll get down to the actual testing of the connectors. Let's get to it. Okay, with the instrument cluster out of the way, we see we're left with 3 main connector blocks. Each one of these connector blocks has its own color. We have the white one, yellow one, and blue one. And the factory service manual actually refers to these connectors as C2, which is the white one, C3 as the yellow one, and C1 is the blue one. Now they're all identical. They have the same number of pins. They're the same look. They're just different colors. Now the first thing you need to do, or at least the first thing that I did in order to do this, was remove the little zip ties that secure the wires to the block itself. I've already removed them here, but there's usually a zip tie that goes around the end of the connector and holds these wires tight to the connector. The reason I removed that is because I want to remove the outer shell of this connector. And once the zip tie's off, we just stick a flat blade screwdriver in here, a small one, and you can kind of just pry it off the end. And then you're left with your raw connector block here. Now it's important to take note of the orientation of the connector block. This is a 2-row style connector block, each one of these are, and they have 26 pins. The bottom row is 1 through 13, 1 starting at the left, 13 ending at the right, and then the top row is 14 through 26. So 14's here on the left, 26 is here on the right. And you know left and right is because the left has the indented notch here and the right has the protruding notch here. So again, all of these connectors have the same setup. We have 1 through 13 on the bottom, and then 14 through 26 on the top. Now the reason I removed the shroud is so I could actually see what color of wire is going to which pin. And that's important when you're going to the factory service manual because it tells you which color at which location should be getting what voltage. So before we even get to measuring voltage on these connectors, you first want to draw out a diagram for each one of these connectors, making sure you note the color and connector number, C1, C2, and C3. Inside of each one of those diagrams, make sure you put the correct notches so you know that 1 is here with the indentation and 13 is here with the notch to the right. So before we start taking any measurements, let's make our diagram. Okay, with your diagram all drawn up now it's time to set up your test equipment. Now, taking one of your test leads with the alligator clip on the end, you want to find a ground from underneath the dashboard. Really, the ground that I recommend using is the ground that the instrument cluster uses, which is right near the steering column. I'm going to try and show it on the camera. No guarantees that I'll be able to show it very well, but basically there are 3 wires going to a bolt underneath the dashboard here. And you can kind of see it through here. There are 3 wires going to it, and I'm gonna take my alligator clamp here and hook it onto one of the ends of one of those wires. And the reason I'm not hooking it up to the bolt or the nut itself that's actual ground is because I want to verify that the wires going to the ground are grounding correctly. So I've just got it clamped to one of the ends of the wires there. So with that in place, we've now got our ground for our test equipment. This is how we're going to be making sure we've got a complete circuit when we're testing for voltage at the connectors. So with that there, now it's time to get our positive side hooked up. Okay, so I've got my voltmeter here. So the black is the negative side of the voltmeter. So we'll just connect that to our green alligator clamp down here. It's kind of hard to do with one hand. Ooh, let's see. Okay, so there's our negative hooked up. Now, the positive side is what we're actually going to be using to probe our connector. But this probe on this is too wide to actually get in there and get each individual wire inside that connector, which is why we need the other test lead, which has the alligator clamp. So I'm just going to hook this up real quick. So we'll see that I've connected the other alligator test lead to my positive side of the probe. And then this receiving end of this alligator clip, I'm going to connect to the safety pin that I've got over here. So let me get that hooked up. Okay, so you see that I've opened the safety pin and I've got the alligator clamp hooked up. So this is how we're going to probe each individual slot on each connector to check for voltage. Now before we get going, let's move our voltmeter over to the 200 setting so we can see a full 12 volts if needed. And now we're going to reconnect the battery if it's disconnected and turn the ignition key to on. You'll know it's on because you've got a light that illuminates here where the instrument cluster would have been. And then you'll take this first connector, which was the white one originally, and you just start going down the line here and start taking your readings. If your ground is good, then you'll start seeing readings. If there's a break in the wire, then you won't see readings where you're supposed to see readings. Just to start things off, don't even worry about what reading you should be seeing. Just go through here and record what each pin is reading. So for example, we'll just kind of start here. In the number 1 pin, again, it's the bottom leftmost pin on this connector. See, we don't get a reading there. Just keep going down the line. Some of these holes don't even have wires going to them, so obviously you're not going to get a reading. And even slots that do have wires going to them doesn't mean you're going to get a voltage reading either. So just keep going down the line and just kind of wait till you see some sort of reading come through. Okay, so that whole bottom row on this first connector didn't have any reading. Oh, here we got a reading, 11.7 volts. So this is where you would start recording your voltage reading on your diagram. So this is the pin 26 on that white connector. So you just pull up your handy dandy diagram right here. And then on pin 26, say 11.7. And then I would also recommend writing down the color of wire that's going to that pin. So this is a purple, this is just straight purple. So I would also write down, purple. But again, if it has a stripe with it, mention the stripe as well in your diagram here, just so you know exactly which wire is getting which voltage. If you don't get a voltage out of wire, don't write it down. You don't want to clutter up your diagram. You just want to record where you're getting voltages for each connector. So I mean, that's pretty much it. You just keep going down the line. You just got to make sure the voltage that you record corresponds to the correct number pin in the connector block. So then we got another 12 volts. So you kind of see the idea here. So you just want to go down and do that for every single connector, for every single pin. If you're having trouble taking readings on the front side of this, then you can always come from the back side where you see the metal pin for each wire and you can read it from there as well. So it just depends on which way you want to go. I find it easier to go through the front side. But again, if you don't have a safety pin small enough, you might try going from the back side of the connector. All right, so once you've gone through all of these connectors and you have your diagram completely filled out, then it's time to go and reference the factory service manual. So let's go take a look at that now. Okay, so after going through all the connectors, you should have some voltage coming across. Not too many of them. I mean, I think I have less than 10 actual pins that had any sort of voltage coming out. But if you didn't get any voltages, then I would first start with your ground connection. Try a different ground. Again, it needs to be a raw metal chassis ground, something that will go all the way back to the battery in the back of the car. So if you don't have a good ground, you're not going to get any good voltage readings. Now the alternative is there could be either a fuse blown or a break in the wiring somewhere that will also give you no voltage through the connectors. But more than likely it's probably a bad ground, so start there first, try a different ground. But hopefully you got some voltages through your connector, and they should look something like this. So starting off with the blue connector, I've got 6 different pins with voltages. Most of them are about 12 volts. The yellow connector had 0 voltages coming through to any pin, and then the white connector had 3 pins with voltages, 2 of them being about 12 volts, and then one of them, the 23 pin, was about 4.8 volts. I've got the Bentley service manual for BMW E30s right here on the bench, and on page 24 of the electrical system section of the manual is a box diagram right here, and this diagram shows what the voltage should be at a particular pin inside of a connector block. We'll see this first row in the table says on the C1 blue connector, the 23 pin with voltage on should read about 12 volts. So if we go to our C1 connector, we go to our 23 pin, we'll see that I got 11.8 volts, which is about 12 volts. So that's pretty good. So we know that pin is good. We just keep working our way down this table, comparing the connector with the pin and which voltage we should be seeing when the ignition is on. And if we check off each one of these rows inside of this diagram, then we can say, you know what, our instrument cluster is getting power because the wiring is good, our grounds are good, and we can eliminate that from our troubleshooting. So, I mean, that's pretty much it when it comes to testing the power connectors for the instrument cluster. So if you get all good power readings here, but your instrument cluster is still having issues, then you know your problem is more than likely inside of the cluster itself. It could be the SI board batteries, it could be one of the solder joints on one of the circuit boards in there, or in my case, something completely else. The actual gauge pieces were faulty on mine, at least that's what I believe they were. So I ended up just having to get a whole new cluster that I knew worked. So the reason I took my cluster out for this video is because I'm going to replace the odometer gears on my speedometer right here. I've got a new set of odometer gears. This is a pretty easy operation, and we'll just go ahead and run through that. I'm not going to go too step by step just because there's tons of tutorials again on how to do this, and it's really pretty straightforward. So let's just run through it and get it done. Okay, so I've got the speedometer separated from the rest of the instrument cluster, and right here I've got a new set of odometer gears. These were made by Garagistic, and I think they're about $28 shipped, so not a bad deal. Granted, it's a lot of money for some little plastic gears, but you know what? They serve an important purpose. To get into this, once you have the speedometer outside of the cluster, you'll see that there are 2 little screws. Now let me back up a moment. There's actually 2 different kinds of speedometers. There's a Modometer one and a VDO one, and they have different style assemblies. They have different gears, and the way you get inside there are a little bit different. This is a Modometer one, so really what I'm going to show only applies to Modometers. Sorry everyone who has a VDO gauge, but I'm sure they're very similar as far as disassembly goes. So anyway, you need a flat tip screwdriver, a small one, and then you just have 2 flathead screws that need to be undone. Okay, with the screws removed, we take off this little plastic cover. Then we'll see we have our odometer gears here. Okay, so I've already been in here and removed one of the gears. I was just checking to see how deteriorated it really was, and it just turned to basically wax and crumbled in my hands. So one gear is not actually shown here, but I did take a picture before I disassembled everything originally, so I know how to put everything back. But you can see the pinion gear from the motor, the odometer motor itself, is completely disintegrated, and the rest of these gears are really no better off either. So we just need to start by pulling them off the shafts. And I'm going to put them in kind of the order of disassembly here, just so I know general order. We just want to match them up, make sure we're putting the right ones to the right spot. I noticed the gear set didn't come with this green gear, and that's a good thing this one's in good shape. I don't know if it's supposed to come with that gear or not. This is the one that feeds directly to the odometer assembly. Hopefully yours is in good shape too, because mine was. That's a little bit concerning. But anyway, so I guess we just put the green one back in since it's in good shape. Okay, so we need to figure out how to get this little brass or bronze knurled bushing off of there so we can slip on our new pinion gear for the motor. See if we can kind of cut it off. There it goes. So I just used some dikes. I did see this tip on the Garagistic website. So you just kind of use some dikes and pinch that bronze bushing until it deforms enough to slip off the shaft. It is a press fit type deal, so if we can, just soft metal so it's easy to get off there. Okay, next then we're going to hold the shaft that the new pinion gear goes on so that we can isolate the pressure we're going to be applying. Push this gear on. And then we put this gear over the top. Odometer should now be counting. We can see that it is. If we turn that, we can see our trip meter cycling here. So this is pretty much good. Look at that. It's counting perfectly. Very good. Now it's time to get this thing reassembled. Alright, so there we are. We tested the connections on the backside of the instrument cluster, and we changed out the odometer gears in the instrument cluster. So again, this was just going to be a short video. That's all we were looking to cover on this one. In the next video, we're going to change out the rear subframe bushings on the car, as well as try and increase the rear ride height just a little bit. So stay tuned. We'll see you guys again soon.